Hello people, good evening. Today I'll be discussing about the synthesis of nitrobenzene. It is basically an experiment, but before talking about our experiment, I just want to let you know about some of the certain details, like what is a nitrobenzene. As the name itself shows that it is a compound which contains nitro group on a benzene ring. It has the molecular formula C6H5NO2. It is water insoluble pale yellow oil. It has an almond-like odor and it freezes to give greenish yellow crystals. And on reduction, nitrobenzene gets converted into aniline. So during the reduction process, the O of nitro group, it gets replaced by hydrogen atoms. But we are not going to talk about the reduction of nitrobenzene. We are actually going to talk about the synthesis of nitrobenzene. So nitrobenzene is usually produced through nitration of benzene. During this process, a nitro group is introduced into the benzene ring. And as a result, one or more of the hydrogen atoms on the benzene ring, it gets replaced. So as you can see in the chemical equation, benzene is our starting reagent, and a mixture of concentrated sulfuric acid and nitric acid is used, and as a result we will get our desired product. And the mechanism of nitration is electrophilic aromatic substitution. It is basically a two-step reaction. In the first step, the formation of the electrophile occurs, and our electrophile will be nitroneamine, which is NO2 positive. This NO2 positive, it gets attached onto the benzene ring through the following electrophilic substitution mechanism. Now I'll talk about the experiment. The materials required are mentioned. You can take a look at them. And the chemicals required will be benzene, sulfuric acid, and concentrated nitric acid. Remember, the concentrations that are mentioned were used during my experiment in the lab. You can change them according to your experiment. You can study chemical hazards and the precautions on your own. I'll head towards the procedure part. So the first step during the procedure was the formation of nitrating mixture. For this purpose, you will take a beaker and place it in an ice bath and add 3 ml of concentrated H2S of HNO3. We will then add 2.5 ml of H2SO4 in small quantity with frequent mixing in the above beaker. This will be our nitrating mixture. Remember, you can take these concentrations using a pipette or a dropper depending upon the availability of apparatus in your lab. We will then take another flask and add 2.75 ml of benzene in it, and we will place it in an ice bath. Now nitrating mixture will be slowly added to the flask containing benzene, and always remember to shake the flask in between so that the reactants get mixed. After about 5 minutes, you will see the solution will acquire a yellow color with two separate layers. The top layer will be the organic layer and the bottom layer will be the acid mixture layer. We will then arrange a hot water bath with thermometer attached to it and place the above flask containing solution into the water bath for about 30 to 45 minutes. After heating, you will transfer your solution into an ice cold distilled water. As a result, the organic layer will go down and our product will be formed, which is nitrobenzene. You will separate the product using a funnel and a filter paper and will calculate its yield. Before talking about calculations, I just want to let you know that always write your procedure in the past tense. Now for calculations, you need to know about the theoretical yield of product and actual yield of product. For theoretical yield of product, you need to know about the mass of benzene. For this purpose, volume of benzene used is given. Density of benzene, you can calculate it from, you can take it from literature, and you can calculate the mass of benzene using the formula of density. Density is equal to mass over volume. You can rearrange your values and calculate the mass of benzene. So as we know from the chemical equation that 1 mole of benzene produces 1 mole of nitrobenzene, and we can use this information to calculate how many grams of benzene will produce how many grams of nitrobenzene. For actual yield of product, actually I mentioned in the last step in the procedure that you need to filter your product in order to calculate the yield, but you can actually calculate the weight of beaker. The weight of beaker containing ice cold distilled water, and when you will transfer the solution into the beaker, you will calculate the weight of beaker plus product, and from these information you can calculate the weight of product. So for percentage yield, you will need to know the formula, which is actual yield over theoretical yield multiplied by 100, and so you can calculate your percentage yield, which was 7% as of my experiment. Thank you.